Okay, a bullet going straight up at some speed strikes the bottom of a block and sticks in it without going through. The bullet and block combo fly 1.14 meters up in the air. Okay, so scenario one, we've got a block somehow just sort of like there. Maybe it's resting on a thing, and we've got a bullet, right? Like, we don't know how fast it's going. And then in the next scenario, the bullet has stuck in the block. And the bullet and block are moving upwards at a more majestic pace because there's a lot more mass there, right? And then in the final picture, the bullet and block have risen some distance and aren't moving anymore, right? They've reached the top. All right, let's see. Bullet hits the... Okay. I think we're going to have to work it from here, right? So this distance is 1.14 meters, right? And so we're going to figure out this velocity. So I know here we've got mgh. And here we had 1/2 mv squared. Right, so I'll set those guys equal. The masses cancel, right? So I've got 1/2 v squared equals 9.81. Then our height is 1.14. All right, I can do this. Square root of 2 times 9.81 times. I get 4.729. 729,355. All right, approximately, right? Do we have that? Oh, we got it. We got that part right. Okay, this is good. I have a feeling we're going to get this one right too. Okay, so we're going to go bullet, momentum of bullet first, right? So 0.0063 times v equals, what's our combined mass? It's 1.65. 1.65 plus 0.0063 is 1.6563. So that equals 1.6563 times 4.729355. Okay, so this is the velocity, right? We figured that out. Okay, I've got it. I'm all over this. All right. That times 1.6563 divided by 0.0063. Wow, it's going really fast. That speed of that bullet was 1243.4 meters per second. I don't know if bullets go that fast. That'd be like 3,000 feet per second or something like that. 4,000 feet per second. We could figure that out. Times 3.281, 4,079 feet per second, right? Okay, anyway, there it is. So again, with these things, right, you want to just set it up, figure out how fast it had to be going to rise 1.14 meters in the air. And that's the speed of the bullet and block right after the collision. And then set up the momentum expression to figure out how fast the bullet had to be going to give the block that much momentum. Okay? But just be careful. You can't say that this kinetic energy is the kinetic energy of that bullet. That's just not true. Or this potential energy is not the kinetic energy of that bullet, because in this collision, most of the kinetic energy is lost to heat. Okay? Just momentum is conserved in collisions. I don't think there's anything else I could say. I could say nitwit, oddment, blubber, and tweak. And then I'm done, I feel like.